All right, guys. So today we're going to talk about how to become an employable data scientist. And I'm going to share some tips for creating a project that stands out from the rest of the crowd. And the big idea I want to present today might be a controversial one. And I know that some of you might vehemently oppose it, but it's this. You don't need a job as a data scientist to get data science experience. You don't need anyone to choose you for a job or an internship or a co-op position in order for you to gain real world experience as a data scientist. And believe it or not, we all live in the real world. I don't know of any of us who lives in a non-real world. All the foundational knowledge and tools of the trade, they're all open source, but it's going to be up to you to put the pieces of the puzzle together and showcase your skills through a project. In careers like accounting, actuarial science, finance, and so many others, this concept of having personal projects to demonstrate your understanding and command of the field, it doesn't really exist. And the fact is that data science is a unique combination of several different knowledge bases and skill sets. You've got critical thinking, problem solving, programming, math and statistics, business acumen, et cetera, et cetera. There is really no one skill called data science. And I firmly believe that data science really can't be taught, but it can be learned. And I think that continuous learning and online courses are an excellent way to learn the individual tools of the trade, but they don't teach you how to work and think like a data scientist. And again, that's because data science is not a set role. No problem you face in the real world will truly ever be the same. But the principles, the process of solving these problems can be learned. And with a solid set of principles in place, you can abstract away the details, see the problem for what it really is, and be able to approach any problem and solve it. So let's take a few seconds here, and I want everybody to write into the chat what a data scientist does. And I want you to take note of the different responses that come up. So go ahead and put into the chat, what does a data scientist do? And just look at all these different responses that come up, right? That's because data science isn't really well defined, but I want to share my definition with you. What does a data scientist do? A data scientist applies a principled methodology to find answers to interesting and valuable questions or challenges by building reproducible systems where the input is data and the output is a decision. That's my definition of what a data scientist does. But if you want to become a data scientist and create a project that will get you hired as a data scientist, you need to start thinking like a data scientist. There's a unique mindset you need to adopt. And this mindset is what makes careers in data science so special. To think like a data scientist, you've got to think like a scientist, think like an engineer, and think like a business person. Why do you need to think like a scientist? Well, you're going to be using advanced analytics, investigating motivations, looking for patterns, and trying to understand the why of it all in a systematic manner. Scientists use critical thinking to discover knowledge using the scientific method. So just like a scientist, you start by researching. You'll have to hypothesize and come up with some possible solutions or explanations for the problem you're working on and think of ways to gain new knowledge. You have to test these hypotheses. You're using statistical methodology to confirm or disprove those hypotheses. And you got to measure your results very carefully. Why do you need to think like an engineer? Well, you have to write code, build systems, deploy models, and automate things. You need to engineer systems that are reproducible, testable, extensible, portable, robust, reliable, and efficient. You need to build systems to solve problems. Why do you need to think like a business person? Well, typically as a data scientist, you're going to be hired by a business. And business is about two things: making more money or spending less of it. If you don't make money, you go out of business. You need to demonstrate that you have business acumen, that you can identify real world problems and come up with real world solutions that solve them. That's it. You don't get a paycheck because you know 100 different algorithms or because you know all of the ways to solve hackering problems. You get paid to solve problems. So before we jump into it, here are the 5 tips I'm going to share with you, but I want to state a few key points very clearly here. First, there is no best data set to use for a project. No hiring manager is going to be impressed with the data set that you use. There are absolutely bad data sets that you shouldn't use for your portfolio project, like the Iris, Titanic, Boston Housing, or any of those toy data sets that you can find in the scikit-learn dataset package. These are great for when you're learning the basics and getting comfortable with the fundamentals, but ultimately they're toys. You wouldn't show up to build a house with a Bob the Builder toy hammer. So don't show up with a portfolio project that uses a toy data set. There is no best problem you can work on. What matters most is the process you use while building a project. When you're at work as a data scientist, it's not like you just get a buffet of problems to choose from. You take whatever problem the company needs solved and you use your methodology to help solve that problem. What matters is that you have a principled methodology. There is no best algorithm that you can use in a project. There's a concept that Leo Bryman, the guy who invented random forest, talks about. It's called the multiplicity of good models. Essentially, what it says is that for the same set of input variables and prediction targets, a complex machine learning algorithm can produce multiple accurate models with very similar but not the exact same results. Also, I want to end the Python versus R debate right here, right now. There is no best programming language or tech stack that you should use. It's going to change depending on the company that you're at. But if you understand the principles of what needs to be done, the tool you use becomes only a detail. Back in the days, before chainsaws, we used axes to chop down trees. A hand axe could still chop a tree just as well as a chainsaw. Both tools do the same job, cutting down a tree. The only thing that's changed is the passage of time. And finally, instead of thinking about what type of project you should do, you should think about what a project should do for you. So now let's get into these 5 tips a little bit further. First, find an interesting question. Let your own curiosity and obsession drive the type of project that you do. It will show in your work quality and in the final presentation of your project. Are you interested in how the music you listen to affects your daily activity levels? Well, then you can download your Spotify music data, your wearable device activity information, and do an analysis. Are you wondering if the cops in your city are disproportionately doling out parking tickets in poor neighborhoods? Go to your city's open data portal, download that data, and do an analysis. Are you interested in a particular industry? Well, do some research into the industry, find out the common problems that data scientists face, and try to create a project around that. Are you interested in a specific type of business model? Well, then do some research, find out some of the common problems data scientists are working on in that business model. You are only limited by your creativity when it comes to finding an interesting question to work on. And here's the thing, it doesn't matter if it's interesting to me or to the rest of the world. It matters that it's interesting to you. Create a project analysis plan. This is probably one of the most important pieces. For data scientists, nothing is more fun than diving right into some data to answer questions. But unfortunately, with there being an infinite number of ways to summarize and model data, you could spend weeks working with data only to discover that you haven't really answered anything or figured anything out. Sometimes you might even feel more confused than when you started. One solution to this problem is to have a guardrail in place that keeps you on track and doing work that is relevant. An analysis plan is that guardrail. You need to break down this large project that you're undertaking into smaller, more manageable, discretely defined tasks. The idea is that before you start looking at data, you write down everything you plan to do with that data. Then, as your analysis progresses, you keep track of how much of that plan you've completed. When you've done everything in the plan, well, you're done with your project. You not only have a way of knowing whether you're off the plan, but you have a tool for tracking progress and keeping yourself accountable. If the task in the plan is actionable, it'll be easy to tell whether you are making progress. It'll also make doing the analysis easier because you won't have to worry about what to do next. Instead, you'll be able to look at the analysis plan and select the next task to do. Show your work and share your thoughts. Don't leave it up to the person reviewing your project to guess what you're thinking. Walk us through your notebook with commentary. If you have some visualizations in your notebook, be sure to clearly label the axes. Tell us what we're looking at. Why is it interesting? Make it easy for the person reviewing the project to understand that what it is that you are trying to communicate. And the easiest way to do this is by leaving copious comments, both as markdown cells and as doc strings for your functions. I'd even suggest splitting the data understanding and exploratory data analysis phases into two notebooks. One where you're profiling your data and understanding what's in it, and another where you're doing more hands-on exploratory analysis. A clean repository structure, this comes back to thinking like an engineer. A huge part of your workload is building systems that use analytical methods to solve business problems. And to create systems, you need to think like an engineer. So let's get some clarity on what we mean by systems. A system is just a set of connected parts forming a complex whole. In particular, a set of things working together as part of a mechanism or interconnecting network. So when you're working out a solution, reproducibility for your system is a must. That means the solution that you built is testable, extensible, portable, robust, reliable, and efficient. You don't want to be writing spaghetti code, copy pasting your code from cell to cell all over the place, or having a notebook littered with ad hoc solutions. The process of doing data science work is the process of building software. That's a fundamental component of nearly every data science project. And the truth about software is that everything is simple until it's no longer simple. And if you're working by yourself, or you're working on an easy problem, or you're doing an academic project, you can do all sorts of things and only you have to know how it works. But that's not a scalable method for doing data science teamwork. And it sure as hell is not a good way to impress recruiters, potential teammates, or hiring managers. So how do we take some of the lessons from software engineering and use that in our day-to-day work? Well, the thing with software is that's not just a simple matter of programming. It's about organization, documentation, reproducibility, and reusability. That's why the first step before you even begin to write code for your project is to structure your repository in a clean and organized manner. That means you need a place where your data lives, a place where your documentation lives, a place where your visualizations and model output live, a place where your Jupyter notebooks live, a place for references, a place for your source code and helper files to live. You just need to organize your repository. A couple of great frameworks I like is Cookie Cutter Data Science and Kedro. Finally, you need to create a presentation. The fact is that as a data scientist, you need to communicate results in a clear, efficient way with just the right amount of details. The consumers of your work are often not data scientists themselves, and the last thing you want to do is confuse them with your communication. Otherwise, they won't buy into your ideas. That's why writing executive summaries will become an important activity in your professional career. And if you can demonstrate your ability to do this in a project, you'll stand out from the hundreds or thousands of people applying for the same job. There are three main purposes for this executive summary. It serves as a brief, concise overview of your project. It provides an outline to the main points of the project, as well as an analysis of these points, and it gives recommendations for future action if applicable. At the very least, it should provide a conclusive statement of your findings. So you should consider waiting until after you've completed the entire project to write the summary. That way you can easily determine the main points of your report and include these points in the summary. Once you've created an executive summary that lives in the report section of your repository, be sure to make an accompanying slide deck with the key findings, and then take it one step further. Do what your competition is not willing to do. Record yourself presenting your project. Showcase your communication and storytelling skills, and then put that up on YouTube. So just a couple slides left, but that's the crux of the 5 points that I wanted to bring up. None of these things that we talked about today require you to actually have a job title as a data scientist. They're mindsets and techniques that you can implement today so that you can move yourself from an aspiring data scientist to an employable data scientist. My hope is that you take these tips and apply them not only in your project, but throughout your career. Guys, let's keep in touch. Check me out on my podcast, the Artist of Data Science podcast. You can find that everywhere. Visit theartistofdatascience.com. Website is still kind of shaky. If you guys build websites, reach out to me. I need help with that. But get on the newsletter. And on that newsletter, I'll send you a personalized link to join me for office hours that happen every Friday at 4:30 p.m. Central Time. Also, go ahead, open a new tab, go to my LinkedIn page and smash that follow button. Also, guys, shout out, we got the largest protest in human history happening right now. I just want to put it out there that I stand with the farmers. So I've got a platform, and I'm just saying that I support them. That being said, any questions?
Awesome. Thank you so much for that, Harpreet. You have so many fans here with us today. It's actually crazy. And I love the tips that you shared. So thank you so much for that. The website again is The Artists with an S, right, of Data Science. I always get confused with the S.
Yeah, theartistofdatascience.com with an S, yeah.
Plural, got it. So you asked the question early on about what does a data science do? And we have so many answers to that question. Solves problems with data, predict the future. This one's probably my favorite. Create magic with data. This is what Art heard from a client. Solves real problems with data, makes data useful. So many different answers here. Answers business questions with data.
I love it.
This is another great one. Herds cats and data. So I'm going to go over to some questions here. So there have been, sorry, the chat is just going really, really fast. But Let's start with this one from Arun. What types of project ideas should data science beginners start with?
Yeah, so this goes back to the very first point I made. It's about an interesting question. So Arun, I don't know you, don't know anything about you, but I assume that you have some interest in life, right? So if you have some interest in life, why don't you explore how you can apply data science methodologies to that interest that you have in your life? Maybe you don't have any interest in life. That's cool too. But maybe you have an industry that you find fascinating. We'll go find out the work that they do in that industry and try to recreate a project around that problem statement.
Thank you for that. And it's interesting, a lot of comments about people feeling like they're in a bar or relaxing somewhere with the way you delivered the presentation. It's like talking data science with a beer. So I thought that was funny.
I had to slow it down a little bit.
Yes. Well, it's good to pick things up and then slow things down, right? So David's asking, for those without an ideal CV, how would you advise people in hiring managers to first find your work?
Definitely include a link on your resume to your GitHub profile, right? And then when you're reaching out to people at companies, maybe they ask for a CV, just include a link to your GitHub profile in that section. But when you reach out to hiring managers and you're sending them messages on LinkedIn, just point them directly to your GitHub profile or wherever it is that you store your projects.
Mm-hmm. Thank you. We'll take one more question and then a comment. So is it better to publish on YouTube, Medium, or LinkedIn? I think I know your answer.
Yeah, I'd say, I mean, the thing is you could publish it on YouTube and cross-post it everywhere. So publish once, create once, publish 5 times, right? Across all mediums, including.
Yes, Gary Vee says to repurpose one piece of content 64 times. So if you posted it on Medium, you can read out the article and summarize it on YouTube and then post both of those on LinkedIn. There's so many different ways to repurpose. And then we'll wrap things just because of time with a comment here that I agree with. Kushal says, can't get better than this live class by Harpreet. So thank you so much, Harpreet. I definitely got a lot of value. And like I said, there are so many questions. We can literally spend all day going through them right now. So if you have time to hop over to LinkedIn and address those, that would be great.